All right, so as I was saying, concerning these examples we just did, we have x plus 2 multiplying each other, and our final answer is x squared plus 4x plus 4. Let's see a second example. Let's take a second example on how to multiply the two polynomials. So we have, for example, example 2, we have, let's say, x or 2x plus 4. I have 2x plus 4, bracket, let's say x minus 1. X minus 1. The same principle applies by taking the first term, multiplying this, the second term, multiplying the next term, and the next second term in the first bracket multiplies the next, and the last term multiplies that. So we write our answer. So we have 2x multiplying x, this gives us 2x squared. 2x multiplying minus 1 or negative 1 gives us minus 2x. 4 multiplying x gives us plus 4x. And 4 multiplying negative 1 gives us minus 4. Now the next stage is to find if we have like terms. Of course, we do have like terms at this level. So we are going to have 2x squared plus, remember, a negative number adding to a positive number, we take the sign of the bigger number. So we have plus 2x minus 4. So our final answer is 2x squared plus 2x and minus 4. Alright, let's take a third example. The third example, now with the different signs, or the same signs but negative this time around. We have, let's say, 2x squared, for example, minus 4x multiplying, let's say, let me just take a simple one. Let's say 2x again minus 4, for example. So same thing applies. We are going to have the first term goes, which gives us 4x squared. The next one goes, which gives us minus, because this is 2x multiplying negative, gives us minus 8x. And the next term multiplied, this gives us minus 8x and plus 16. So we check again if we have any like terms. We have to add like terms. So our like terms, we have 4x squared minus 16x plus 16. So our final answer is 4x squared minus 16 plus 16. Now, if you look at the pattern is occurring, we are going to come to a conclusion very soon. Now, let's take a common example again. Any question? I guess we're on track. Any question? All right, I guess no questions. All right, so again here, let's take a third example. A third example, we have, let's say, x plus 1 into x plus 1 into x minus 1. X plus 1 into x minus 1. So we are going to have the same pattern. We have x into x, which gives us x squared. X multiplying this, which gives us minus x. 1 minus this gives 1 multiplying this gives us plus x. And 1 times that gives us minus 1. Now, if you look at the same thing again, we have like terms, which gives us x squared. Minus x plus x gives us 0. So these two answers will modify themselves. Our final answer is x squared minus 1. Now, this brings us to a certain conclusion, which we can talk about the identities of a polynomial. Identities of a polynomial, such as if you have a plus b all that square. A plus b all that square, it means just like we have 2 squared is the same as 2 times 2. It means we should open or we should factor out that number twice to get the answer. Same, likewise, we're going to have a plus b all that square gives us a plus b multiplying a plus b. So it is a reversible process. We have this, we can have this process, and we have this, we can come back to this. Alright, so it means that if you have an expression multiplying expression to the power 2, it means open up that expression twice. The next one is having a minus b on the square gives us a minus b bracket a minus b. A minus b bracket a minus b. So it means that if I open this bracket twice, and my final answer here will be the same procedure, we are going to have a times a gives us a square, a times b gives us plus ab, b times a gives us plus ab, and the b times b plus b squared. So again we have like terms, which gives us, our like terms gives us a squared plus 2ab plus b squared. So when we have an expression in this form, our final answer should be of this form. Now the next part, again we follow the same pattern. We are going to have a square minus ab plus b squared. So when we add our